Paper for 7-3. We're doing 7-3 right now. 7-3 notes. Okay, today we're going in a little bit more on parallelograms, some things more about parallelograms. Okay. What is a parallelogram? Yep.
It's a four-sided polygon where
Yes.
all four sides, so you got two sides that are parallel and two other sides.
Okay, the opposite sides are parallel to each other. So it's a four-sided figure with two pairs of opposite sides parallel. So anything that can be written like this, where they're, it's not the same size, where they're parallel to each other, the little arrow means they're parallel. You've seen symbols like that, it means parallel. So a rectangle is a parallelogram. A square is a parallelogram because they're parallel to each other. The slanted parallelogram, the slanted square or the slanted rectangle, either one. Anything else that you can think of that's a parallelogram?
Octagon.
An octagon is not, because it's not four sides. That is an eight-sided figure.
But it's just two sets of parallelograms. Think about it.
Kind of, yes, but okay, we'll come back to that. Okay, so a quadrilateral. This is kind of interesting because they're parallel to each other like this, and these are parallel. Then the distances on these sides, their opposite sides, are always equal. So if you have a parallelogram, the opposite sides are always equal. Or it goes backwards. If you know that the opposite sides are always equal, then you know you have a parallelogram. But this is a true statement about parallelograms. And that's something that you can use. If you know the sides are, you can say, oh, it is a parallelogram. Okay? So that's one thing. Okay. The other one, we talked about this a little yesterday, but the opposite angles are always equal. In any parallelogram, the opposite angles are always equal. Now in a square or a rectangle, they're all equal, because that defines them a little bit more, but in a parallelogram, you know that they're always equal. So opposite sides and opposite angles are always equal in a parallelogram. Okay. Okay, you can also prove that you have if the opposite sides are equal and parallel, then you have to have a parallelogram. Okay, so if you know that you have two sides that are equal and that they're parallel to each other, you do know that that's a parallelogram. Or if you have a parallelogram, you can say the opposite sides are equal and they're parallel. I mean, all this kind of goes round and round in circles, things you can say. Okay. The other thing is the diagonals in any parallelogram, the diagonals bisect one another. Okay, so if you think about a parallelogram, if you draw it somewhat right, if I draw the diagonals, this is equal to this, and this is equal to this. they bisect each other. Okay, so those are things that you can find out from that. Okay, so the diagonals, which are those lines that go from opposite vertices of the parallelogram to the other one, those then bisect each other. They don't necessarily form right angles. When do they form right angles? When would the lines be perpendicular and bisect? Yes.
In like a square or a rectangle?
Okay, in a square or a rectangle, do they actually become right angles? It's a question. Look at the diagonals. Are those at right angles?
I guess it's only in a square.
Okay, let's see if it's in a square. Are those right angles?
With each other.
Yes. So in a square, they are perpendicular because those lines are the same size. Okay, but in a rectangle, they're not. We just know they bisect each other. Yes, they're all the same size, but they're not necessarily in a form of 90-degree angle. Okay. So that's the things about parallelograms. All those kind of things that we can say. So that's basically what they're looking at in 7.3. They're just giving you more information about parallelograms and what kind of things you know about them. If this is a parallelogram, it applies also to squares and rectangles, because if you draw your thing, there's a hierarchy. That's not, I don't know how you spell hierarchy, something like that. So we start with quadrilaterals. Like, that's the widest. That's quadrilaterals, anything that's four-sided. Okay, so it encompasses everything. Okay, so quadrilaterals is the big thing. With inside quadrilaterals, we have convex, okay, which is mainly what we're talking about. So we'll kind of, I'm going to just split it. Okay, we have convex and concave. So I'm going to actually, yeah, that works. Okay. So in convex, we have, remember, concave is where you have one side that caves in like that. So that's a concave. Okay. Convex is where you don't have any like that. So then the next form is, when you're going down, is a trapezoid. It only has to have one deal of parallel sides. But inside of a trapezoid, we actually find parallelograms. It's just a little bit more specific. It just has to be, so parallelograms are also trapezoids because they do have one side that's parallel. Okay, so we know that parallelograms come in there. Then we know that a rhombus is a type of parallelogram, along with a rectangle and a square. How is a rhombus and a square different? Anybody remember what a rhombus is? No? Rhombus is equal sides, but it's not got 90-degree angles. So rhombus has all equal sides, but it does not have 90-degree angles. Okay, so they're different. Also in a parallelogram, we have not in a parallelogram, it's not in a trapezoid. So we have another kind of branch. This is one branch. We also have the kite, which is a parallelogram. It's a special one because it has two equal sides at the top and two equal sides at the bottom. So it's different. They are not parallel. Okay. So those are different things that we're looking at right now, is all the different quadrilaterals, and we're specifying the different kinds that we have. So that's kind of, all squares are rectangles, parallelograms, trapezoids, and quadrilaterals. All rhombuses are parallelograms, trapezoids, quadrilaterals. So you can, if you're down here, then you are also the ones up above you. Okay? Kites are only convex, and they're quadrilaterals. Okay? So they fit in the quadrilaterals convex section. Okay, so that was parallelograms. A little bit about all the stuff you can know about parallelograms, which really is kind of nonsensical, but anyway. 4. We are going into 7.4 now. I already kind of gave you a hint on this. 7.4 has to do with rectangles, which we've already talked about, squares, and rhombus. Hey, plural rhombus. Oh, ES, okay, rhombuses. I always find it interesting how you make it plural when you have S at the end. It changes all the time. So, let's just look at a square. Well, let's start with a rhombus. A rhombus is any quadrilateral where all sides are the same. So a rhombus, I guess a square fits into that also. So a square is also a rhombus, which is kind of interesting. So a rhombus, all sides are equal. Okay, that's a rhombus. Doesn't matter if they're at 40, oh gosh, if they're at 90-degree angles or not, they're all equal. Okay, so inside this, a square is a rhombus. It's just more specific. A square has equal angles. So it has equal sides and equal angles. So this is a square. But a rhombus can be more, there's more things to a rhombus than just squares. You can have other ones that don't have 90-degree angles, and those are still rhombuses. Okay. A rectangle is basically all angles, all angles are equal and opposite sides are equal. So a rectangle, a square fits in here also because so a square is a rectangle. Because if you look at it, it fits the definition. This one has all equal sides and equal angles.
Aaron, I want you.
Okay. So a square fits as a rectangle and a square fits as a rhombus, but rectangles are not rhombuses because rhombuses have to have all sides the same. Okay, so you cannot have, a rectangle is not a rhombus. Okay. And ask me how often I use the word rhombus. Never.
Once a year.
Never. Well, when I teach it. Okay, yes, you got me. If I was just not a teacher of math, I would never use the word rhombus. Okay? But that's something it's just one of those things. They classify everything. Have you guys ever noticed scientists like to put things in classifications? Mathematicians are really kind of scientists. We just study numbers instead of studying other things. But numbers do represent our world just like other things. Okay? So they classify them. It's like if you go into biology, you will classify your animals. There are mammals. There are amphibians, reptiles. There are all sorts of classifications. You could go down a whole hierarchy. I don't know with all those. It's the kingdom, the phyla, the class, the I don't remember all those things. If you've had biology, there's a ton of them. So, but we do classify, and that's what they're doing here, is they're giving different definitions to different types of figures. That's all they're doing, okay? It's nothing magic. There's just the definitions they gave, the words they used to describe these figures. That's all it is, okay? So, one, basically, both of these fit into parallelograms. So rhombuses and rectangles are parallelograms. So if you have a rhombus or a rectangle, you're going to have a parallelogram, which is what I told you before in the parallelogram section, that rhombuses and rectangles all fit in there, and squares. So it's basically the same thing. Okay? So these are all parallelograms. Some things about the diagonals. The diagonals of a square. Now let's start with the rectangle. So here's my rectangle. Okay. What do you think is true about the diagonals? If you drew that rectangle accurate, what's true about the diagonals of a rectangle? We know they bisect each other because it's parallelograms. Okay, so they bisect each other. What else? If I look at them, what do you know about those? Yes?
The two angles on the longer sides seem to be more obtuse than the angles that are
Well, that's true. Okay.
asymmetrical.
But they're actually the same size. The diagonals are equal. Okay? So this is, they bisect each other, and the diagonals are the same length. So what you actually get is these are all the same in a rectangle. Okay? Because they bisect and they're the same length, then you get all four portions of the diagonals are equal. Okay, so that's something you can say. In a square, or let's do a rhombus. That's a tilted square. Well, both sides are the same. I can't. Okay, let me do a slanted. If I can do a slanted. Okay. It's not a true square. Probably hard to see from my drawings. Okay, in a square or a rhombus, they bisect each other. Okay, and they are perpendicular. To one another. Okay, so in here they form right angles. And this one, they're all going to be the same size because it's also a rectangle. In a rhombus, they are perpendicular, but they're not necessarily, well, because it's equal, I think they also bisect. And so these are all equal also, just because they're all the same distance, same length. Okay. So those are the things you can know about the diagonals. These things are actually good when we're actually trying to build things, because you can square things up. You always have to try to square things up. And if a wall is not built square, Have you ever seen a wall that was not built square? Okay, it might not be off by much, but it really screws up if you're doing cabinetry on that wall. Because it's gonna show. If it's not exactly square, your wall, if it's not perpendicular exactly, or if it's got a little bit of a lean to it, you will find out when you go to put cabinetry. Or you will go to find out if you put like your floor, if it's not perfectly square in your room's not square, so if you put squares down like this of rug, you will find out because it won't go even, right? I was putting flooring in my house. When I bought it, I put in some wood flooring, well, fake wood flooring, okay? I found out my room was not square because at the end, when I got to it was a rectangular room like this, okay? When I got to the end of it, I had to cut at an angle the last piece. So the last piece was wider here, and then I had to cut it, and these pieces didn't, so I gradually had to cut this, so it got, and then finally up here, there was a whole piece missing. So it was not square.
Was it supposed to be?
It was supposed to be. It's a rectangular room.
They probably.
So that is definitely a problem when your room's not square because all of a sudden it's not going to fit like you think it is, and you're going to definitely notice. And I wish I'd started on the other side because where you see this is where I walk, and over here is where this is the outside wall. And it's more where I have furniture, and you probably wouldn't have seen that it wasn't square, but now I have it over here, and I can see that the room is not square every time I walk through it, which is kind of a bummer. So, anyway, but these kind of things are important when you're building, and so they use these concepts that these are perpendicular and that they bisect each other, or that your diagonals are the same length. That helps them to know that you have something square. You could throw a diagonal across, and that way you know it's actually square. Okay, so that's something they look for in building stuff, because otherwise you're going to notice if cabinets and stuff are not the same, and you're going to notice when you get perfect squares to put on that wall. You're going to notice that. Or if your windows are not perfectly square, the window won't fit in correctly, and you get leaks. Okay, I have a story about that. When we were building our house way back, we put in a header up above the window, and the window wouldn't fit right. We had it slightly off. My dad, who loves chainsaws, decided he was going to square it. So he got the chainsaw out and squared the window with a chainsaw because that header is so thick. So that's how he squared the window so our windows would fit and not have leaks in them.
Did it work?
Yes, it worked. It did.
Skills.
It
That's
worked.
pretty
He
crazy.
was really good with a chainsaw.
Yeah.
He just was really
Especially
good.
back then.
So. I use chainsaws. They're fun to use. I like them. So, okay, so that's basically 7374. Those are all the things we can tell you about rectangles, rhombuses, squares, parallelograms, quadrilaterals. We haven't really talked about a trapezoid, but it's so simple. The only thing in a trapezoid is that two lines are parallel. It doesn't matter. They're never the same length. They're just kind of, a trapezoid only has to have one set of parallel lines. Okay, so that's what you're going to work on now in these sections. So we're going to do a few in class just to work on those. So we'll get up to the boards again and work on those. Okay.